I no longer need this frame rate dropper node. Welcome back to another Zombie Prison Break devlog. This devlog, I focused heavily on optimizing my blueprints. Last week's version was giving me terrible screen tearing, so I decided to focus on optimizing. I ended up doing a lot of research on how to optimize blueprints this week, and wanted to share my new knowledge about it. That means this devlog will end up being a bit of a tutorial and a devlog combined. Step 1 to optimizing blueprints is just like my opener. Get rid of this frame rate dropper. I was calling 5 different things off of it, which is really bad. Event tick gets called every frame, but lots of YouTube tutorials use it because it's easy and convenient to use. It's also hard to imagine how much of an impact it can cause. Let's say my game runs at a consistent 60 frames a second and I have the 5 things being called from tick. That would mean 300 things are being called every 1 second. That's a lot for the computer to handle. And for me, that's just on my character blueprint. I'm using tick in other places as well. So here are the ways I was able to avoid using the tick node. One of the easiest ways is to add this event, set timer by event, and place it in event begin play at the end. You can use this node as a slower version of event tick. It's better than using tick than delay to do an action, because if I put a print node before the delay, you'll see it is still called every frame. All you have to do is set up a custom event of what you would plug directly into tick. So I made a custom event for regenning health. Make sure to set the check mark to looping so it consistently checks. If you don't check it, it will only play once, and that's not what we want. Then the time is how often you want the custom event to run. It's set up exactly like a delay node. If I plug 1 into the time, it will run once a second. 0.1 equals 10 times a second. Then what I have is 0.075, which is equal to 30 times a second. I'm assuming if you're playing my game, you will want it to run at least 30 frames a second. That seems to be a good minimum standard for frame rates, so that takes away one of my 5 tick sections. The next thing I did was look at my crosshair spread code. It's a simple concept. When the player is moving, spread the crosshair. When the player is still, have it close back up. The only thing that dictates this code is movement. I started with a third-person template, so I have this section. I've done a couple edits to it, so it will look a little different from the template. The axis values on move forward and move right are floats that say what speed the player is moving at. If it's 0, the player isn't moving. Any other number, the player is moving in some sort of direction. For my code, it was as easy as just adding this to the end. You'll notice I have this branch that says if the player's velocity is greater than 0, spread the crosshair. You will want to add in some sort of branch similar to that. To add on to this, my sprint checks are only movement based also, so I found a way to add it on. So now I only have 2 things left on tick. Another good way to eliminate the tick node is to make custom events. I was originally checking if the player was sliding every frame, but I was able to do research to find other ways to make the player slide. Unreal Engine has been out for a long time. Whatever you're trying to do, there's a million different ways to do it differently. Try to find a different way to do it. For me, it was a tedious job just to find and learn about this simple move to location node, but it works exactly the same as what I had in tick and eliminates another section of code off of my tick node. The last thing I needed to get off tick was to check if I was aiming down sights or not. I was having to check this every frame because aiming sights and unaiming sights were set up as functions. Functions are set up to where the code is called instantly. You can't call a delay in them or any other time-sensitive nodes. One way around this is to use timelines. Originally, I was using interp nodes and get world delta seconds to slow down the aiming process. These 3 nodes made this smooth aiming animation. Now, I'm using a timeline to do that. All of the code is very similar, except it's just not in a function now. The timeline allows me to replace the interp nodes with lerp nodes that accept a float from the timeline, which is better for performance. So to recap, the ways I found out how to eliminate the tick node is to use the set timer by event node, use built-in move nodes, and on a note, the move nodes do call once every frame, but I think it's good practice to keep tick clean if it can be placed elsewhere. Next, we'll be finding a new way to code what you have on tick, and finally, timelines. These are the ways I was able to get my code off of tick. If you have a piece of code that has to stay on tick, there's also a cool node called set tick enabled. If I had to leave my sliding code on tick, I could have used this node to activate tick only when the player is running, because you can only slide from a run. Then I would turn tick back off when the player is walking. The other way I optimize my code has to deal with casting. I cast to my third-person character a lot in other blueprints, and it's expensive to cast. The way around this is to cast once in event begin play, then store it as a variable. It's cheaper to call the stored variable than the cast. I don't know why this is, but I felt a big difference. After I optimized my code, here are the results. I'm running the game at a pretty constant 60 frames a second with virtually no screen tear. I'm not done optimizing yet though. All I did was optimize the blueprints. I can still optimize the level with level streaming, and I'm sure other stuff I just don't know about yet. Also, during this process, I was able to play around with my regen health code. Before, it was hard to tell how much health you had when you've been hit a couple times because the screen flashes red, then goes back to normal. Now, the closer the character is to death, the more red the screen will be. You won't guess where I got this idea from, but I got it from my staple comparison game, Call of Duty. It works the same in Call of Duty and is an amazing way to notify the player of how much health they have without saying a hard number like 50 out of 100 health. That is what I accomplished this week. I hope I was able to help someone out with optimizing their code. I'll link an official Unreal Engine optimization video I watched that helped me. It's an older video, but it's still relevant. As always, you can find my game on seanmercer.itch.io, and that link will be in the description as well. Thanks for watching.